right, we want to look at what is called the line of best fit. And there's two different parts we're going to have to concern ourselves with. So let's look at this. Let's say we have a bunch of dots here. What we're trying to find is what line would fit in here that would be as close to every one of the dots as possible. So you and I might say, hey, we drew a line right like that. That is a line pretty close. Most dots are just a little bit away from it. So that's a pretty good fit. So that'd be the line of best fit. Now, do know we were drawing, in this case, a straight line, which means it would be of the form y equals mx plus b. All straight lines are of that form. We know that we normally write equations y equals 3x plus, 5. We always have a number in front of the x and then something right here, the y-intercept. Now, if it's a straight line, we have to remember we're doing y equals mx plus b. But we're trying to find the line of best fit. Now, what if we saw a bunch of dots like this? It doesn't look really like a straight line. What does that look like? That looks like some parabola maybe is coming in here. Now, remember, parabolas, we have like an x squared plus so many x's plus some number here, and then there's some number out front here sometimes. So we need this guy. The quadratic is going to be of some form y equals, we like to say a x squared plus then some number here in front of x and then plus the c. That's important because we're going to have to use that. So let's say they give us this. They say, hey, find the line of best fit for these points. So what we're going to want to do is come in and plot all these points and see where they are. Now, they might be like this, and then it would be a straight line, a linear line. Or what if they were like this, then it would be a quadratic. They'd sort of be of that parabola. So we want to go and plot those. So we're going to go to Desmos and plot those. So here we bring up Desmos. Now, how do I put in a chart? Well, I come to this screen and I hit the plus up here on the left. So I'm going to hit plus. And I'm going to say, hey, table, give me a table. And then I'm going to fill in those numbers. Now, I already did that to save us time. And here are the numbers. And here are the little green dots that show us. So we're like, oh, this is a linear line. So what is the equation that fits that best? So what we do is we're simply going to come right here in spot 2, and we're going to say, hey, tell me what line fits that best. Now I have to know, is this a quadratic parabola? No, it's a straight linear line. So I want to put in the y equals mx plus b. Here's what I do. I type y. Now, notice that our points up here are y1 and x1. I have to make sure I put a sub 1 here. So I just hit y1 and it recognizes, oh, you're talking the elements. You're looking at the elements that you have up in your list. I'm like, yes. Now, I don't want to put equals. I want to say approximately. And it tells it, hey, I want you to find me the line of best fit. That's the tilde that's right up in the upper left on your keyboard, that little squiggly. That's a tilde. So y sub 1, okay, approximately mx plus b. So I do m, and I don't do x. I do x sub 1 because I wanted to use my data. Now you see it's pulling a line here and going, hey, this guy looks pretty good. But we need to put the plus b. And now it gives me everything. It actually tells me, hey, the R squared stat, simply the closer it is to 1, the more perfect it is. That's about a 99.9% accuracy. So that's great. And it tells me the parameters is what we want to look at. It tells me the slope is about 1.98, so pretty much 2. And the y-intercept, the b value, is about negative 0.97 to about negative 1. So this equation is really about like a y equals 2x minus 1. That would be what we would guess this line of best fits, about a y equals 2x minus 1. It tells me the stats right here with my m and my b down below. So let's go back and look at another problem. So that was for that line of best fit. Well, what if they asked us these points? So they want us to plot these. So I'm going to come back, and I've done that one also. Here they are. They've plotted right here. And that looks, I can sort of see a U shape looking like it's coming through. So I want to find the line of best fit. Now, is this linear? No. This regression is not going to be linear. This is going to be quadratic. So we need that form what did we say the form was back here? Oh, let's see. We said this would be this guy right here. Okay, but remember, we're going to do y sub 1 tilde. We'll put in a x sub 1 squared plus a b x sub 1 plus a c. That's what we're going to have to put in there. We're going to have to remember to do that. So let's take a look. Let's try it. So we come here. Let's find the answer. Y sub 1, I put my tilde. Try to put my tilde. There we go. Now there's a value a, something in front of it. Maybe it's a 2, maybe it's a -1. I don't know. That's what this is going to tell us. And I put x, and I hit 1, and it brings up the sub 1. So it says, oh, you're looking at the data here. Now I need to square it. I could put caret 2. The other thing you can do is you can go to the keyboard, and you can just put the squared, and then it'll come in, and I can hit that to make it go away. Plus bx sub 1 plus c. Now it gives us all the data. Notice it draws the parabola in there. Then it hits almost all those points perfectly. The r squared value says, hey, it's almost 99.98% accurate. Perfect hit. The a value, the value in front of that x squared, is a 0.20. So write that a right there. That a would have been a 0.2. The b would have been a 0.378. And the c value would have been about a -1.6. So that would give us the equation of the line of best fit for this set of data.